All right, guys, so I'm trying a different setup here. I wasn't happy with the quality of the last video, so I'm gonna try just something different. Unfortunately, I don't have a stylus yet. It's on the way. It's Amazon sending it. So I'm just gonna have to kind of screencast here, or screen record, and I'll pull up the answer key and I can show you guys some stuff, but I won't be able to write on this. If I tried without a stylus, it would look like a 5-year-old's writing, so I'm just not even gonna try that. So let's take a look here. Again, you guys are supposed to try this before you watch this video, so make sure you've tried this FRQ. But we've got two functions here, f of x and g of x, and I actually, oh yeah, I can tell based on the graphs that the log functions on top, log functions are curved like that, and the x to the fourth is the bottom, okay? But if we weren't sure, again, absolute value whenever we need to, okay? The graphs of f and g shown in the figure above intersect at x equals -2, so they gave us that intersection, and x equals b, so they didn't give us b, so we're gonna have to figure out what that is. Now, I'll show you guys in a second what b is, but I just want to show you guys something on Desmos if you're not aware. So I didn't graph those functions here, but I graphed a couple other ones, and if you want to find their intersections, literally all you have to do is just click on the intersection. So you guys might find it easier at times. This is a way better calculator, and it's free. And so I know you guys already own yours, so that doesn't matter at this point. But this is pretty cool that it can do this for us, especially when it's a decimal and things like that. Even zeros, it'll find zeros if you just click on them. It'll find y-intercepts. All we have to do is click here. All right. So enough about Desmos. Let me head back over to that FRQ. So part A just says find the area between the graphs of f and g. And so first we have to find b. So I'm just going to jump to the answer key here. And this is my second take of this video. The first take I took a picture, not a video. So we're going to try it again. Let me go back up to the top here. But A, again, they set both of them equal. They're going to solve this, again, by probably graphing. And they get that their value for B is 0.781 or 0.782. You don't have to write out the whole value like they did, but we want to use that entire decimal and throughout the rest of the problem. So we either need to write it down or know how to store it on our calculator or something with that value, okay? Now, area, again, it's just a definite integral of the top function minus the bottom function. If you're not sure which one's which, we want an absolute value around the whole thing. It could be inside the parentheses, it could be outside. But I would probably put it outside the entire integral, including the dx. All right, so you get 1 point for setting up the integral correctly. So a definite integral of f of x minus g of x dx. A second point if your bound is correct, if the upper limit is correct, the value of b. And a third point for the answer here. All right, so that was, I think, 3 relatively easy points. Sometimes you make little mistakes, but relatively easy on part A. All right, part B, so it says let h of x be the vertical distance. So let's just stop here for a second. Vertical distance between two things, is just the top function minus the bottom function. All right, it has nothing to do with an integral. It's not area, it's just the top function minus the bottom function, okay? So you can see in the answer choice, they wrote h of x equals f of x minus g of x, that's why. H of x is the distance between the two, top minus bottom. Then it asks, is h increasing or decreasing? So we want to take a derivative. And if at some point you wrote h prime of x equals f prime of x minus g prime of x, you got a point, okay? And then another point for actually calculating that and giving your reason, which would be to say that h is decreasing at x equals -0.5 because h prime is negative at that value of x. All right, so a second point for that. All right, part C, it says the region enclosed is the base of a solid. The cross sections of the solid taken perpendicular to the x-axis are squares. And so we know the area of a cross section is just side squared, or the area of a square is side squared. And so we want in our parentheses both functions together. So f of x minus g of x all in parentheses, and then it's squared. All right, so again, a point for writing the integral correctly. If you got the wrong value of b earlier, that's okay. You can keep using it. So if you got the wrong value of b, your answer is going to look different. Your integral may look a little bit different in terms of the bounds, but they're going to base your work off your answer. Someone will actually calculate based on what you got. Okay, so a point for setting it up correctly, and a point for the correct volume, even if it's not the answer on there based on your value of b being different. All right, so that was another 2 points. Again, it is not correct to do f of x squared minus g of x squared. It's all subtracted in parentheses and then it's squared. Now, D is kind of weird. I don't if we get any points or don't, it's okay. What I care about here is just kind of reading through this, being able to pick up that we're taking a derivative of something, all right? So a vertical line is passing through that solid that was just described in the last part. And it's moving at a constant rate or derivative of 7 units per second. Find the rate of change of the area. And so really what I care about with this is that we know to take the derivative of area here, all right? So the area was our side squared, right? F of x minus g of x, all being squared. And we're taking a derivative of that. Now, I don't want to get lost in the details here. This is not a huge concept. Feel free to look this over. You can even look at the scoring notes here if you're curious. What would they accept? What wouldn't they accept? All that. So let's see. It might be worth it to read that top line right there, just to see if you kind of had the right idea. Even if you didn't have the dA over dx and the dx over t, you could still get a point there. All right. So that's it for this FRQ. Hopefully this format worked better. And again, once I get my stylus, I can make it even better from here. All right, guys, stay flawless.